Okay, so let's now try and see what it looks like when we have numbers inside radicals and numbers outside of radicals. So here's an example. If we had 2 times the square root of 12 times 4 times the square root of 15, what I'm going to do is I'm going to move things around so that numbers inside of radicals are next to each other and can be multiplied, and numbers that are outside of radicals are next to each other and can be multiplied. So I'm going to rewrite this by taking the 2, which is outside, multiplying by the 4, which is also outside, times the square root of 12 times the square root of 15. Now visually I can just kind of see that I'm going to multiply the 2 by the 4 and I'm going to multiply the square root of 12 by the square root of 15. Remember, nothing goes outside of the radical until we get to the simplifying step. Nothing goes outside the radical until the simplifying step. Well, 2 times 4 is 8, and 12 times 15 is the square root of 180. It was inside and inside. I could multiply them together, and it stays within the square root symbol until this step of simplifying. So now I'm back to how do I simplify square roots? What perfect square is in 180? Well, I know that 9 is, but I'm wondering if anything bigger than 9 is. So 180 divided by 16, nope. 180 divided by 64, nope. 180 divided by 36, yes. So 36 times 5. And now it almost looks like we're going backwards because we took two square roots and made them into one, and now we broke it back apart. This is for the multiplying step. This is for the simplifying step. Okay, so 8, take this, the square root of 36 is 6, and 5 stays inside. So I get 48 times the square root of 5. So again, I'm going to let you go back and replay that video if you need to see that again so that it makes sense. And then there's another example for you to try on your own, and then we'll get back together and show you how to make the problems a little bit more complicated as you can FOIL and you can distribute with square roots.